Like I said, we're going to work through this one. This is assignment number 43. We're going to work this together. Try to go over these rules. Try to head you into spring break without a homework assignment. We'll try to get this done while we're here. We're going to start with this first one, which is the outside piece times the whole thing. In order to do that, you're going to have to draw that line, get the whole thing. So when you add that 6 and that 8, what do you get together on this side? 14. What do you write when it's like this, though, the x and the 7? Not. You got to do it as addition, not multiplication. There we go. It's going to be x plus 7. There you go. It's very tempting to do that, so it's very common that people make that mistake. So I want to make sure we see that's what we get when we multiply that. When we add that. So we're going to take and we're going to set up as the outside piece right here, which is 6, times the whole thing, which is going to be 14, and the outside piece here, which is 7, times the whole thing, which is going to be this x plus 7. Yeah, please.
Did you get 14 from 8 plus 6?
Yes, I did. Yes, thank you for asking. Guys, if you have a question, please ask, because the test is coming up when we get back, so I want to make sure you're ready for it. We're doing this together to help you out for spring break, but I also need you to know this stuff. Alright? So, grab your calculators, tell me what 6 times 14. I haven't done these yet, so I need y'all to do this work. 84? Perfect. 84 equals 7x plus, now I can do 7 times 7. 7 times 7 is 49. So we are going to subtract 49 from both sides. Minus 49 minus 49. What is 84 minus 49? 35 equals 7x. We divide both sides by 7. And what does that equal to? 5 equals x. That's our first answer for number 1. Anybody have any questions, concerns, anything so far? Huh?
It don't matter if we put it like how to write it. Like
no, it's going to have an answer blank on the test, so it'll be, you'll take that then and put it on the answer blank. Okay, for the next one, we actually have 2 answers. We got to find x and we got to find y. For x right here, we're going to be dealing with this intercepted arc. Intercepted arcs are equal to double whatever the angle is. To get from the arc to the angle, we're going to cut it in half. So you're just taking that 240 and dividing by 2. What's that going to leave us for this angle right here? 120. Perfect. So my x is going to be 120. To find my y, I'm going to use the idea that every circle adds up to 360 to find this missing piece right here. And I'm going to do 360 minus. Guys, what is the other arc? The blue arc. How much? How much is this arc right here? So I'm doing 360 minus that 240 to get to the red arc, that leftover part right there. What's that give us? It's weird because it's 120. It says same answer again. Feels wrong, doesn't it, that they're the same number? I did this problem at first and I was like, what? And it works, guys. If you want me to show you why real quick. What's half of 120? 60. And then those two would add up to 180 because they make a straight line. And then the circle adds up to 360. Yep. To get the 60, I did. Yep, divide by 2. That is exactly correct. Okay, now on the next one, guys, what do I know I'm going to have to do on this problem based on the fact that the x is on the outside? Because I've got that x on the outside, what am I going to have to do in this problem? This part right here. Factor. I'm going to have to factor on this problem. Up front, I know I'm going to have to factor. This is going to be one that needs some work, so I'm going to have to add these together. 5 and 13 gives you 18. X and 9 gives you x plus 9. And when we set this up, I'm going to do the variable one first, because if we're going to factor, I definitely want that variable term in front. So I'm going to start with x times x plus 9 equals, guys, what am I multiplying on the other side? 5 times the 18. Perfect. 5 times the 18. So I'm going to distribute the x across here. It's going to make it x squared plus 9x equals, I don't do 5 times 18, guys. Tell me what that is when you multiply that on a calculator. 90? Okay, 90. Now, I can't factor unless it's equal to 0, so I need to move that 90 to the other side. So the only way to get rid of a positive 90 is to subtract it. And it's going to make it x squared plus 9x minus 90 equals 0. After you make it equal 0, this is where you're going to make your X or your diamond or whatever your teacher called it to get those numbers. Okay, I'm just going to draw it right here in the picture because there's space in the circle right there, so I can fit it and not take up other space. You can put it wherever you can fit it, guys. My top number is going to be this number at the end, so it's going to be negative 90 on the top. My bottom number is going to be the number in the middle, so it's going to have a 9 on the bottom. Okay, guys, I need two numbers. We did this before, didn't we? These numbers sound familiar. We need the factors of 90. So, guys, we're just going to list them out. I'm just going to list them right here. I'm going to list all the pairs. 1 and 90. Are those 9 apart? No. 2 and 45. Yes or no? No. 3 and 30. No. 4 doesn't go in. Try 4. I don't think it does. No. 5 and 18. Is it 18?
Yeah.
Oh, I do know what the next one is because the next one is 6 and 15 because I switched these two last time, I think. And I think those are the ones that are 9. I think we did do these numbers one time before. 6 and 15 are 9 apart. So I'm going to put 6 on one side, 15 on the other. I need one of them to be negative and one of them to be positive for it to multiply to be a negative on top. But I want them to add up to a positive number, so the bigger number needs to be positive. So which one's going to be negative, guys? The 6. There you go. So here we go. X minus 6, X plus 15. Does anybody have a question where I got any? It's always X and X, unless you're doing one with the leading coefficient. But it's X and X, and then the numbers come from right here. Those are the numbers you put in there. Yes, ma'am?
Do you make the smallest number negative?
It doesn't. It depends on the problem. Okay. If the number on the bottom, let's say I give you a diamond where the number on the bottom was a negative, like negative 4, and you have one of each, you'd want the bigger number to be negative. Okay. If you had it like this and the number on the bottom is positive, you want the bigger number to be positive. Okay. Does that make more sense? Yeah. Okay. Good deal. So what is the opposite of negative 6? Yep, and the opposite of positive 15 would be negative 15. I cannot have the negative 15, so my answer is 6. Perfect. Perfect. Okay, guys, the next one is going to... Oh, go ahead. I'm sorry.
How would you know this type of problem?
Oh, whenever there's an X on the outside. That's what we started with. If there's an X on the outside like that, you know you got a factor. Yep. Hands down. Okay, guys, here we go. The next one. Guys, if I have one radius that's 5, what's every other radius in the circle going to be? So if I draw one right here, and I make this into a right triangle, this radius is still going to be 5. 5. I also need to take this 8 at the bottom. If you have a chord that's perpendicular to a radius in the middle, you're going to be dealing with bisecting that chord. So if this is 8, then each side is going to be 4 and 4. So I now have a triangle that's a right triangle where I know two sides. Guys, if you know two sides of a right triangle, how are you going to find the third side? Pythagorean theorem? So it's going to be a squared plus b squared equals c squared. You'll say it out the long way so you don't have to say the name. So it's x squared plus 4 squared equals 5 squared. The only one that matters where it goes is the 5, guys. It's the hypotenuse, so it has to go last. So that's going to be x squared plus what?
16.
Equals, perfect. Minus that 16, what do you get on both sides? 9. And then, ooh, that doesn't look like a 9, sorry. And then you take the square root. And what is the square root of 9? Perfect. I wrote it wrong, but you said it right. X equals 3. So it's a 3, 4, 5 triangle. Very common special triangle. Okay, guys, the next one. We're looking for this arc. We're looking for this arc. We have nothing connected to this arc, but what we do have is this 30-degree angle. If this angle right here is 30 degrees, then the arc directly across from it in blue right here is going to be what? 60, because we take whatever that angle is and multiply by 2, And that's going to give us the intercepting arc. Now guys, how can I find the other one if I don't have the arc on the other side, if I don't have that other missing piece? Subtract from what? 180. Why can I subtract from 180? This is a what? It's a straight line. That was funny. It is a straight line. However, it goes to the center of the circle. What straight line goes to the center of the circle? Diameter. Diameter. That diameter means it cuts off a semicircle. I heard semicircle several times. It does make a semicircle, which means it's got to add up to 180. So we're going to take that 180 and we're going to subtract that 60. That leaves us what for x? 120. There you go. That's how you would find x. Anytime you have an intercepted arc, meaning the vertex is on the circle, the rule is when the circle, the angle is on the circle, you multiply by 2 to get to the arc. Yep, yep. That's that on, inside, on, or outside rules. Okay, guys, these are both tangent. If they're both tangent, they're going to be equidistant to the center. They're just going to be equal to each other, guys. Just set them equal. Set the 4x plus 2 equal to the 2x plus 8. A lot of people try to make this problem really hard. It's not. Just set them equal. Minus 2x minus 2x. 4x minus 2x is going to be what? 2x plus 2 equals 8. We're going to minus 2 minus 2. We're going to get 2x equals 8 minus 2 would be 6. And then divide both sides by 2, and x is equal to what?
3.
It's 3, isn't it? I'm just asking. I think it's 3.
It's 3.
Okay.
It's 3. Yeah,
I think it's 3. I think, but somebody, I don't know who said it. I don't know where it came from. I think you added 2 instead of subtracting 2, whoever it was. Okay. Anybody have anything on the first 6? Okay, let's pull it down. Let's get this part. So the next 6, here we go. When we have an intersection point outside the circle, the rule is what? You have to divide by 2, but what do you have to do before you divide? Subtract. It is subtract and divide by 2. Subtract and divide by 2, guys. So we are going to subtract the 110 minus the x. So it's going to be 110 minus x. And we are going to divide by 2. And what's it going to be equal to? 15. Perfect. 15. It's a work backwards problem, so it's an equation. We got to solve it like an equation. To do that, we've got to start by multiplying to get rid of our denominator. We're going to multiply both sides by 2. When we multiply both sides by 2, the denominator cancels out. We get 110 minus x equals 30. How do I get rid of that 110 in the front? It is a positive 110. The only way to get rid of that positive 110 is to subtract 110 from both sides. Yes, ma'am?
Could you tell me how you got 30?
Absolutely. I did the multiplying both sides by 2 to get rid of that denominator because I can't leave a 2 on the bottom. So I multiplied by 2 on this side, which canceled out. I multiplied by 2 on this side, and 15 times 2 gave me that 30. Yep. Thank you for asking. When you get 30 minus 110, it's negative something? 80?
Yeah.
There we go. How do I get rid of that negative sign in front of the x? I divide both sides by what number? It's a number. Negative 1. Negative 1. That's going to let me cancel out the negative sign, and my answer will be 80. Okay, guys. The next one is going to be chord segments. These chord segments are just multiplied by each other and set equal. It's just going to be like cross multiplying. You multiply the 9 times the x, that's going to give you 9x. You multiply the 6 times the 5, that gives you 30. It's not going to divide nicely though. Do the math. It does not divide nicely. You're going to get a decimal. You're going to need to round to one decimal place. 3.3. Is that what y'all got?
Yeah.
3.3. I just want to make sure. Did you have to round it? No, just 3.3. Okay. There we go. Okay, the next one, guys. Anytime you have a tangent on the outside, it's going to form a right angle. If you have a right angle, you know you can use Pythagorean theorem to find the missing piece. So in this case, our Pythagorean theorem is going to be 24 squared plus 18 squared equals x squared. All right, these are bigger. Guys, do the math. What's 24 squared? 18 squared? 324 equals x squared. Now, how did I know x squared was going to be last? Because it was my hypotenuse. The 24 and the 18 could have been switched. It doesn't matter. When you add, excuse me, add those together, you're going to get you're going to get 900? Okay. Because it carries over. And the square root of 900, I'm guessing is 30?
Yeah.
Okay. 30 equals x. Okay, guys, the next two there's no work on the next two. People miss these, though, because they do too much to them. Guys, if chords and arcs are equidistant to the center, in this case, this chord is equidistant to the center, it's going to cut off congruent arcs. So these two arcs would have to be the same. So if this one is 32, this one is 32. There's no work on that problem. That should just be an answer. Don't do extra. That's it. On the next one, if you have tangents to the same circle are going to be congruent. So if this one is 5, this one's got to be 5. Now, if this one is 5, because these are both tangents, this one has also got to be 5. It looks bad, doesn't it? Nope. Tangents are equidistant, so 5, 5, 5. Just like this one up here was that these were set equal to each other, but they had algebra in them. This one's just a number, so it's just 5, 5, and 5. The next one, the biggest thing on this is, guys, you're going to have to deal with algebra. Okay? Now there's no factoring, but it is going to be algebra. Guys, what is it when you combine these two and add these two together? Awesome. No issues on that. X plus 8. So, x plus 8 is going to be your hypotenuse. So when you do Pythagorean theorem on this, because it's a right triangle, you're going to do, am I going to put it above or below it? I'm going to start it right here. Okay, here we go. It's going to be 8 squared plus 15 squared equals x plus 8 squared. Now I'm not going to write it as x plus 8 squared. I'm going to write it as x plus 8 times x plus 8. I'm squeezing it in that spot. What's wrong? Oh, you got it? Grace, you won't hand it to her, you're being mean. Or she can reach it. Y'all are goofballs. What is 8 times 8, guys? 64. And, oh, I knew that one. And 15 times 15 is 225, right? I don't know why I asked you that one. I knew that one. And this one we have to FOIL. FOIL, write it above it, F-O-I-L. First, adder, inner, last. I'm going to multiply the x times the x. What is x? Oh, we may have to factor this one. We'll see. We may have to factor this one, guys. I didn't think we did, but we may have to factor this one. And x times an x is going to be what? X squared. And then x times 8 is going to give us 8x plus, oh, I'm tight on space on this one. I don't have any more room. I'm going to write it under here, guys. X times 8 is also going to be 8x plus 8 times 8 is going to be 64.
So small.
It is so small. Sorry, guys. Okay, guys, here we go. What is 64 plus 225?
281.
281?
89.
89, thank you. Equals x squared plus, guys, what's 8x plus 8x? 16x plus 64. And we are going to have to factor this one. I didn't think we had to factor this one. I guess the variable is on the outside. I should know. See the variables on the outside? I didn't even notice that. And then you got the minus 289, because we got to make it equal 0. It's going to make it 0 equals x squared plus 16x. And then we're going to need to use our calculators. What is 64 minus 289? What? Negative 225?
Yeah.
Okay. We're going to have to do a diamond. It's going to have negative 225 on the top, and it's going to have 16 on the bottom. Ooh. Okay, here we go. Now, we know it's not going to be 1 and 225. It's not going to be... Let's do this. I'm going to give you a cheat on this, like a way to kind of like look for the beginning numbers that you're going to start with. Take 225, hit the square root on the calculator. I think you have to type it in second square root 225. Not the negative, just the 225. Let's just see what the square root would be. 15. Okay. 15 and 15. Now we need them to be further apart than that. We need them to be like 9 apart. So I'm going to go, let's try 18. What's 225 divided by 18? 12.5, so 18, no, still not far enough apart. 10 and 25? 9 and 25? There we go. So it'd be 9 and 25. Which one needs to be negative if I need the bigger number to be positive? 9. So it's going to make it my 2 parentheses. What goes at the front of each parentheses? X. What goes at the back of each parentheses? The numbers, right here. These numbers. I'm not trying to trick you. Y'all acted like I was trying to trick you. I'm not trying to trick you. Y'all are like, what? The numbers from the diamond go at the back. So it's minus 9 and plus 25. So it'd be 9 and negative 25, which means my answer is 9. Perfect. Okay. It's only 2 factoring so far. We haven't had too many. Okay, so the next one, ooh, it's not even, guys, what are we doing on this problem? We're finding what? Are these angles or sides? Which one, guys? Angles. These are angles. And you already know this one. What's the x right here? 90. It's a tangent. This is a 90-degree angle, so x is going to equal 90. Period. Once you know 2 angles inside of a triangle, you can find the third angle by adding together and subtracting from 180. Here we go. 90 plus 61 equals, excuse me, 151. And then 180 minus that 151, 29. 29, and y equals 29. There you go. The next one is fast too, guys, because this is going to be a quadrilateral. How do you know? Because you can read how many sides it has. Look right here. 1, 2, 3, and 4. That's 4-sided figure. 4-sided figures add up to 360. We already know 1 angle, but we really already know 2 others also. If this is a tangent right here, because it hits right here at this radii, this is going to be 90. And if this is a tangent, this is also going to hit and make a 90-degree angle. We now know 3 angles inside of a 4-sided figure. We're going to add those angles up. 90 plus 90 plus 60. We're doing good on time, guys. We'll finish this thing. That's awesome. And you won't go home with any homework. What's 90 plus 90 plus 50? 360. Oh, I got different answers. Try it again. 90 plus 90 plus 60. 240. 240. And then you do 360 minus that 240 is going to leave you 120. X is going to be 120. Okay, last one on the front. Last one of these, guys. When the intersection point is inside the circle, what is the rule? Huh? When it's inside. Inside, what's the rule, guys? It's add and divide by 2. When it's inside, it's add and divide by 2. When it's outside, you subtract and divide by 2. So if the intersection point is inside, we're going to add. We're going to be adding the x plus the 60 We're adding the two arcs. And then we're going to divide by 2, and it's going to equal 51. What do I do to solve that, guys? Multiply by 2. It's going to give you x plus 60 equals 102. And then minus that 60, minus that 60. And x is going to equal 42. Okay, there we go. Okay, guys, does anybody see anything on the front they need to ask a question about before we go to the back? Anybody see anything on the front before we go to the back side? Back side's got a lot of naming, the equations, the circles, stuff we've done, old stuff, and then the brand new stuff. Nobody? Okay, here we go, guys. Let's go to the back. Okay, on the back side, we got a lot of naming, guys, so you need to pay attention. Give me the names of these things. It says which arc, so first of all, our answer is going to be an arc. Okay, which arc does angle DAC intercept? So I'm going to trace DAC. What arc does that intersect? DC. Does that make sense when you see it drawn like that?
Yeah.
Is that better? Okay. The next one says which angle intercepts arc, and I'm going to trace it for you, BAD. Now this is the arc. We need the angle that's going to intercept that, guys. In order to get the angle, you're going to start here and you're going to end here. What angle connects through there? D what? DCB. Angle DCB is going to be the angle that intercepts that. Guys, it's going to be about drawing this and reading the picture, so you need to draw on your picture when you have test day. Okay, let me clear that off again. Let's do it again. Here we go. For the next one, what is the measure of angle D? We want this angle right here. Guys, you should already know that. Look at what its endpoints hit. This is hitting the endpoints of a diameter. If it's a diameter, that's cutting off a semicircle. How many degrees are in a semicircle? And if you're getting half that to get the angle across from it, what would this angle be? What's half of 180, guys? 90. It's always going to be 90 when it hits the ends of a diameter and hits a semicircle. So that's going to put that degree at 90. The next thing it asks for, the next thing that it asks for is arc CB. So we need to find the measure of arc CB right here. To do that, we would double whatever angle is across from it. Since there's 48 across from it, what do you get when you double 48? 96. So arc CB would be 96. The last thing that it wants is the measure of angle ACB. ACB. This one right here, guys. So we can find that, guys. This angle right here intersects the ends of a diameter, and it therefore intersects a semicircle. What is half of a semicircle that's going to go right here for this angle? 90. If I now know two angles inside of a triangle, I can find the third one. Okay. I take and add the 48 and the 90. That gives me 138. And then 180 minus that 138 leaves you what? 42. And that's going to be my angle right there, is 42. Perfect. Guys, there's a section just like that on the test. If you did not understand any of that, you need to ask a question when we get done. Come see me one-on-one, ask what you need. It'll be on the next review workshop also that we do on Tuesday when we get back, but there's going to be a picture that's almost identical to that on your test. Okay, here we go. Next one's, oh guys, before we do anything, if this radius right here is 5, then what's this radius right here? 5. And it says, what is the measure of segment DC? 5. You just did that part. That part's easy. The next thing it asks for is this a tangent? In order for this to be a tangent, this would have to be a right angle. In order for it to be a right angle, then Pythagorean theorem would have to work. In order to do Pythagorean theorem, you got to add these two parts together first. What is 8 plus 5? 13. Which one of these three numbers, the 5, the 12, or the 13, goes last? 13, because it is the hypotenuse. This is what it's going to look like. It's going to be, I'll do it over here so there's space. 5 squared plus 12 squared equals 13 squared. If the two sides are equal, you would say yes. If the two sides are not equal, you will say no. So equals means yes. If they're not equal, the answer is no. So here we go. What's 5 squared? 25 plus 12 squared and 13 squared. Perfect. Is 25 plus 144 169? Yes. Because they are equal, then you answer yes, that this is a tangent. Okay guys, this is what we did yesterday, so this should be like easy peasy stuff. Okay, we got to write the equation using this center and this radius. So if I'm going to write it in the equation of a circle, what do I write first? Y'all tell me, because I'm not doing this one. X what? Minus 3. And that whole thing is what? Squared. Plus, what goes in the other parentheses? Good on the signs. Y plus 4 squared. And then what's it equal to as a final answer? 49. Y'all heard that. I knew the circle part was easy peasy for y'all. That's why we did that so quick yesterday. Okay, let's do it again. What's wrong with this problem though? It's a diameter and it's got a 0 in it. Both those are going to be issues for people. Both of those are important to see. First of all, since it's a diameter, cut that in half, but that the radius is equal to what? Perfect. You got to start with that first. The second thing you got to worry about is this 0. When you deal with that 0, what do you write when it's 0 like that for the x? Just x squared, no parentheses, no nothing. For the y, what do you put inside the parentheses? Y what? That's the minus 7. Squared equals, and then what is it finally equal to? 25. Perfect. Perfect, perfect, perfect. Okay, the same thing on the next two going backwards, and then we got one last problem. That's it. We're killing it time-wise, so we're doing good. So I need to pull out the center of this. What would the ordered pair be for the center using this x and this y? Negative 3 and 11. What would the radius be? Because I take the square root of that, it would be 7. No problems on the equation of a circle. That's awesome. For the next one, what would my, and now you do have to be careful, what's the center going to be if this is my x and my y? 0 and negative 2. And my radius is going to be the square root of 576, which is 24. 24. Okay, guys, we got one last problem.
Okay.
Yep, please.
Show me how to do the square root again.
Yeah, on the calculator?
Yeah.
Absolutely. Second, hit the little button that looks like this. Okay, and then type the number 576 and hit equals. Got it? Okay. Good. Anybody else? Okay, this last one, guys, we've done this. This was on our last quiz. It's going to be on the test. I'm telling you up front that it's going to be on there. I wanted to make sure I did one of these just to remind you. Guys, the opposite angles inside of a quadrilateral have to be supplementary, which means they have to add up to 180. So if this one is 100, we would take 180 and subtract that 100. That would leave us 80 for angle X right here. We are looking to find that Y and that Z. In order to do that, we're going to use the arcs and angles that are in this picture already. So I'm going to highlight in blue this angle that I'm going to trace and the arc that it intercepts. So that blue angle intercepts that blue arc. If the angle in there in the blue is 92, what is the arc in blue across from it? Oh, no. It's going to be like 180 something, right? 184. Because whatever the angle is, we double it, and it's going to give us that arc that's across from it. If the whole blue angle is 184, and I've used up 60 for this part at the top, I would take 184 and subtract that 60, and how much would that leave me for my y? 124. And so y would equal 124. Now I'm going to do the same thing, but I'm going to switch colors. I'm going to switch over to pink, and I'm going to do this using my pink angle. Here's an angle in pink. It is going to connect to the endpoints here and here, so we're talking about this arc that goes all the way around to here. If my angle is 100 right here, what is my pink arc when I double that? 200, perfect. I take 100, I double it, it gives me 200, but I've already used up 60 for this top part right here. So if I take 200 and subtract that 60, what is that going to leave me for that z? 140. There you go. Okay. Does anybody have any questions anywhere on this worksheet? Anything they want to go over again? Ask me anything about this. Number 17? Absolutely, thank you. Where is it front or back?
No,
back. Is it one of the arcs and angle ones? Yeah, people really struggle. I'll be honest with you. I can have all the complicated math ones on the front, and then this is the section that tends to get people. Naming stuff, it absolutely is one of the harder ones. So it says, what angle intercepts arc BAD? So I'm going to draw arc BAD. I'm going to go from here, start at B. I'm going to go all the way around through A, and I'm going to end at D. So I'm telling you right now that my beginning and ending point for my angle have to be the end point. So I know it's got to start with D, and it's got to end with B. And all we're looking for is what connects in between it. Is that better when you see it like that? Okay. Anybody else?
16.
Absolutely.